So we are back with example one, and we've got $10,000. There should be a dollar sign there. I will fix that in the Google Slides. $10,000 is invested at 6% compounded monthly. Then the future value of the investment, S, and we are going to use the variable capital S for the future value of an investment through Chapter 5 and Chapter 6. It's kind of weird, I get it, but S is the standard variable for the future value of an investment. After X years is given by that function right there. We're asked to graph this function in GeoGebra and just sort of analyze what's happening to it over time. Now, there are a couple things I need to show you in GeoGebra here. First of all, remember you can copy and paste the function into GeoGebra. And I think we talked about how you can zoom in and zoom out like this. What we're going to want to do today, I need to, on my machine, hold down the Shift button and grab the axis and pull it down. The reason for this is that our graph actually crosses the y-axis at 10,000. And so you'll see my x-axis is staying the same, but my y-axis is coming down. And so this is the beginning of the investment right here at $10,000. And you can see as time goes on that the value of the investment is increasing. Now I'm going to come down to the x-axis, and you'll see that I get a finger unless I hold down the Shift button. If I hold down Shift, then I can move the x-axis and sort of see what's happening to the value of this investment as time goes on. So from 0 years to 5 years, it looks like it gained almost $5,000. So it went from there to probably about $13,500, which is not a huge difference, right? But if we continue growing over time, and so I grab this axis and I pull it over again, you'll notice that as I look further into the future, this line here is actually getting steeper as time goes on. So again, I'm going to hold Shift down. I'm going to pull down my y-axis to get a larger view vertically. And you'll see if we look at the slope here, if we were to put a ruler against this, that it would be going about like this, which is not very steep. But as we get over here to about 30, it's really pretty steep. And so I'm actually going to pull this graph over to where I can see something like 60 years into the future. And we're going to take a look and see what happens to the value of this investment as it matures and grows from 0 years out to 60. So in the beginning, you can see again, the slope of this line is almost flat. It's hardly growing at all. In 10 years, it only went up this much. The next 10 years, it only went up that much. The next 10 years from 20 to 30 is a pretty big jump vertically. The next jump from 30 to 40 is even bigger. The next jump from 40 to 50 is very steep. Now this is gaining value extremely quickly. And then from 50 to 60, look at this. It's gone from $200,000 to $350,000 in 10 years. So this person made $150,000 in 10 years for doing nothing. Now, the reason I bring this up is these exponential functions and the way that money works, as I mentioned in my notes, time is fertilizer for money. So let's play this out for a couple generations of a family. This person started with an investment of $10,000. Let's say that their family leaves that money invested all the way out for 120 years. So like 3 generations of their family holds that investment until they capitalize on it. And so again, I'm holding down Shift and just grabbing the axis so I can kind of find what's going on. This family, after 120 years, would end up with what looks like about, what's that number? It's a huge one. 1, 2, 3, 1, 2, 3. About $12.5 million in 120 years. And so this $10,000 turns into $12.5 million in 120 years for doing nothing because the family let it sit there and grow. Now again, even now that I'm zoomed out this far, you can see that here in the beginning, it's growing super slowly. The slope of this line right here is zoomed out this far, almost 0. And then right about the 60 to 80 year mark, it starts to go up a lot faster. Then 80 to 100 much faster. Then 100 to 120 super fast. And so again, I mentioned in my notes, this is why rich people stay rich, because they know that this is what money will do if they leave it alone. And so you may have heard the term generational wealth. If there is a family that had a person that had $10,000 to invest 120 years ago, and that family has not touched it, it has likely turned into something like 12.5 million by now. And so, again, it's important to understand that we can use money to make money, and that we can literally leave generations after us a gift, a small gift today. $10,000 is not necessarily small, but we can leave generations after us a small gift today, relatively speaking, that will become a gigantic gift later on in life. And so that's the discussion for number one, everyone. What is the graph doing and what is happening to the value of this investment? You can see that the longer it is invested, the faster it is growing. And so let's play this out even a little bit further, out to 200 years. Notice how far I have to go up this graph to get over to 200. So 200 years would happen right about there. Let's grab a point and just sort of estimate after 200 years what this value would be. 1, 2, 3, 1, 2, 3, 1, 2, 3, about 1.5 billion, 1.6 billion, somewhere in there. So 200 years after this person invested $10,000 for doing nothing, it turns into almost 1.6 billion. That's what today's lesson is going to lesson, and the rest of this course is going to be about, everyone, is how to make things like this happen with your money. So again, I hope you enjoy the ride. Let's go ahead and deal with part B there. Let's pretend that this $10,000 was put into an account to be used for a child's college education on the day that they were born. The family has two options when the child turns 18. So we're only talking about way down here at 18 years. You can see it's not going to grow some ridiculous amount in that period of time. 18 years is not going to be long enough. Again, money is fertilizer, or time is fertilizer for money. They have a choice when the child turns 18, withdraw the money from the account and pay for tuition, or leave the money in the account, take student loans, and then when the child graduates at age 22, use that money to pay off the student loans. So let's get back into what's probably more of a realistic thing here, everyone. I'm holding shift to do this. I'm not going to ask you to turn in pictures of your graphs or anything. We can actually do most of this through Wolfram. I'm just trying to provide a visual here of what the money is doing over time. And so if I get back here, everyone, to what looks like about a good graph right here, 18 years is right here. So that's going to be nearly $30,000. And we'll use Wolfram to get an exact number. 22 years is something like almost $38,000. And so by leaving this money in the account for 4 more years, again, time is fertilizer for money, they will go from about $29,000 in the account to $36,000 in the account. They will probably make about $7,000. Let's jump over to Wolfram, and we can do exactly what we did for Geogebra there. We can just punch that in there. We're trying to replace X. We need to put a multiplication symbol there. So we want to know how much the account will be worth after 18 years. Let's feed that to Wolfram and see what we get. So after 18 years, we have $29,367. And please do me a favor, everyone. Please, please, please round to the nearest hundredth here. We are talking about money. So for number one, after 18 years, the account is worth $29,367, and then round correctly, please, 66. So over a period of 18 years, this family has made $19,367.66 for doing absolutely nothing. I'm going to pause my video really quick and add the math to the top of that before I move on. So at 18 years of age, that account will be worth that amount of money. We also need to consider whether or not we should leave the money into the account to pay off student loans when this person turns age 22. Now, there are more factors at play here. I really just wrote this problem to sort of exhibit what's going to happen in the next 4 years. I'm going to take a moment to write the math down on my iPad, and then I'll be back with Wolfram to get the answer in a moment. So I've got the math there, everyone, and I'm going to go back to Wolfram and change that now to 22 years and see what we get now. So 37,311. 0.29. So after 22 years, the investment is worth $37,311.29. So, as you can see, everyone, if we look at both of these sort of next to each other, by leaving the money in the account for an additional 4 years, it grows about $8,000 more. Knowing what I know about student loans and student loan debt, if I was the holder of this account, I would definitely take student loans and then leave this money in the account and pay the loans off afterward with this money, because I know that there is no way that the student loan interest is going to accrue $8,000 in interest over 4 years. And so my advice, if I was this family's financial advisor, the questions are, which option is better? Withdraw money at 18 or 22? Does it make a big difference, and why? Yes, it makes a huge difference of $8,000. So I would say leave it, let it grow. Pull it out at age 22. To pay off the loans. Your advice may be different. Again, there is a little bit of room for interpretation in terms of all that there, everyone. The piece that is rock solid, though, is that in 4 years, the value of the investment goes from $29,376 to $37,311. Again, $8,000 of growth in just 4 years.